Okay, today we are going to talk about a new lesson, complex numbers. Right before, we knew how to get the value of x if we have like that equation, x squared minus 1 equals 0. It's easy for me to add 1 here and 1 to the other side, so x squared equals 1. So the value here, x equal plus or minus 1. That's pretty easy. But what if I have x squared plus 1 equals 0? Okay, let me add negative 1 here and negative 1 here. So here is x squared equals minus 1. Uh-oh, that's a problem. Why? Because to get the value of x, I have to get the square root of both sides. So if I get the square root of x squared equals the square root of negative 1. So x equals plus or minus square root of negative 1. Here's a problem. I got used to get the square root of anything means that to multiply the things times itself to give me that number. So there is no way to multiply anything times itself to give me negative, because I know that negative times negative equals positive, and positive times positive equals positive. So none of those gives me negative. So how could I get negative 1? Actually, this problem confused a lot of scientists how to resolve this problem. So a lot of people avoid it, skip it. There is no way to figure it out. And some others like, we have to find a way to do it. So finally they figure out that the solution is to say that, to give it a name. So they called the square root of negative 1 an imaginary number. And now they found a solution, or at least a definition for this number. So as a symbol for this imaginary number, they call I. So instead of using the square root of negative 1, I could say I. So here I would say x equal plus or minus I. Okay, let me go backward. That means that I equals what? Equals the square root of negative 1. And this is the first rule of our lesson today. I is the complex number. So the definition of complex number, its number is complicated. I can't get the square root. It's a square root. That's why I call it imaginary, because it's not real. Okay, so from this we can go and do some examples. Before going to examples, if I equals the square root of negative 1, what do you think the I squared would be? I squared would give me the square root of negative 1 squared. I know that square goes out or cancelled out with the square root, so that would give me negative 1. So now I have two rules. I equals square root of negative 1, and I squared equals negative 1. This is my second rule for today. Okay. Let me take some examples for my lessons today. How about example 1 for today? What is the square root of negative 36? Let's compare between those two numbers. Uh-oh, that's not negative 1, but it has negative. If we go back to the properties of roots, okay, we know that I can split that to square root of negative 1 times square root of 36. Now I have two numbers are defined for me because I can get the square root of 36, right? As well as I have a definition for the square root of negative 1 as I defined it before. I know that this would give me I. And what's the square root of 36? It's plus or minus 6. So here times plus or minus 6. So if I put those together, I would say that would equal plus or minus. And of course that I will put the coefficient first, so there would be 6i. So 6i would give me negative 36, or negative 6i would give me as well negative 36. How about to get that backward to make sure that my answer is correct? 6i times 6i. 6 times 6 is what? 36. And I times I is I squared. What is I squared here? Is negative 1. So that's going to be negative 36. And if I get it under the square root, it's going to be negative 36. So write this is the same like that. Okay, let's get another example. Example number 2. Square root of 125, okay, excuse me, negative 125 divided by square root of 5. How about this one? I need to use the properties of the square roots as we talked about that before. So, for the top, for the numerator, I can say that this is square root of negative 1 times. What's 125? It's 5 times 5 times 5. So I could make this square root of 5 times square root of 25. Is that clear? And write this down, square root of 5. Now simply, if I simplify, I can cancel those out together. So that would equal, excuse me, square root of negative 1 times the square root of 25. I know that this is what? This is I. And what's the square root of negative 5? It's plus or minus 5. So here, my answer would be plus or minus 5, what? I. Pretty easy. Try to find the square root of -1 and get it aside, and now you have a real number. And deal with the real number very simply, and you're going to reach the solution of your problem. This is my second example. So from that, I can make a form for my complex number. The form of complex A plus BI. This is a real number. The coefficient here is a real number as well, and this is the imaginary number. So this part could be a product of a real number and imaginary number. And the first part is a real number. So this is real. This is real imaginary. Let me get an example for that. How about 2 plus 5i? 2, a real number. 5 is a real number as well. But 5i, the product is no longer real, because real times imaginary is an imaginary number. So 5i is an imaginary number. And this form is the form of the complex number. As I knew the form of the complex number, it's pretty easy to do some operations on the complex numbers in this form. So let's go through some examples, and that going to make it clear, and so that we can see that. So let's take 2 or 3 examples. Let's say for addition. How about add 2 plus 3i negative 3 plus 2i. Right now we are using calculator, and when we add 2 numbers, like this number plus that number, and hop, this is the total. But before that, if I use my manual calculation and I want to calculate 25 plus 11, I put them underneath each other, and 5 and 1 is 6, and 2 and 1 is 3. So I get the answer is like that. If I know well how to do that way, that would be very easy to add or subtract here. Let's see that. Let's get this number right down here. Negative 3 plus 2i. And this is plus. I will add the real numbers together, and I will add the imaginary number together. So 2 minus 3 is what? Negative 1, right? Plus. 3 and 2 is what? It's 5. But how could I say that? Oh, 3i and 2i. Okay. Forget about this. This is an apple, and this is an apple. I have 3 apples and 2 apples. So how many apples do I have? 5. So that would be 5i. And this is the result that I want to see. This is the result of, or this is the sum of 2 plus 3i and negative 3 plus 2i. Very easy, right? 5 plus 3i times 2 minus I. Let's distribute. 5, 2 minus I, plus 3i, 2 minus I. 5 times 2, 10, minus 5i, plus 6i, minus 3i squared. Okay? 10 minus 5 plus 6 is plus I, right? And minus 3, what is the value of I squared? Is negative 1. So negative 1. So this 10 plus I minus 3 times minus 1 is plus 3. And 10 plus 3 is 13 plus I. Look at this. This is the form A plus BI. This is what I got. 13 plus I. All right, one more example for something else. What if I have conjugate? The rule of conjugate, usually if I say A minus B times A plus B equals A squared minus B squared, right? That's what I have studied before. But the form of complex number is different. There is I here. So it's A minus BI times A plus BI. Actually, what's going to happen is that going to be the plus. Let's prove that. Distribute A times A plus BI minus BI times A plus BI. A squared plus ABI minus ABI plus, minus BI squared. So here is A squared. This is plus, this is minus, is cancelled out. And this is here, here is, this is both squared. So this is minus B squared, I squared. What is I squared? It's negative 1. So this is A squared minus B squared times negative 1, which is going to be A squared plus B squared. So if I give you an example and I say that, okay, give me the answer of a conjugate, like 7 minus I times 7 plus I, what should be the answer? So here, 7 times 7, just like square it, 49, okay, plus 1 times is 1, so that would equal 50. This is the answer. And the conjugate of the complex number is different than the conjugate of the real number. The real number, we have a difference between them, A squared minus B squared. But here is A squared plus B squared. Okay, last thing for the lesson of today is to go through i's. What if I have, like, I equals the square root of negative 1. I squared, this is square root of negative 1 times the square root of negative 1 equals -1. What about I cubed? This is I times I squared, which is -1 times the square root of -1. So that would equal negative square root of -1. Okay, what about I power of 4? I power of 4 is I power of 3 times I, which means negative square root of -1 times square root of -1. Negative -1, which is equal 1. So I power of 4 equals 1. So I is the square root of -1. I squared is -1. I cubed is negative square root of -1. I power of 4 is 1. Okay, how about I power of 5? I power of 5 equals I power of 4 times I, which is equal 1 times I, which is square root of -1. So it's again square root of -1. What's I power of 6? I power of 6 equal 5 times I, which is going to be square root of -1 times, what's I? Square root of -1, so that would be -1. I power of 7 is 6 -1 square root of -1 times, excuse me, square root of 6 is -1 times square root of -1, which is negative square root of -1. And 8 is the square root of -1 times the square root of -1, excuse me, that's negative square root of -1 times the square root of -1, which gives me 1. So look at here. Square root of -1, -1, negative square root of 1, and then 1. Again, square root of -1, the same. -1, the same. Negative square root of -1, the same. 1, the same. So what does it mean? It means that I have a cycle, and my cycle is from 1 to 4, and then it repeats itself each 4 power. So if I say that I power of 9, it's the same, equals I power of 5 equals I, which is square root of -1. If I say I power of 12, it's the same, equals I power of 8 equal same, I power of 4 equals 1. So from that, it's easy to calculate, to compute the I and its power from that rule. And by finishing that, we are done with the lesson of today, the complex numbers. Thank you, and see you in another videos.